there, this is Dr. May. Welcome to our video on solving two-step equations. Now, I did a previous video, which I will put in the cards here, that I solved one-step equations. But really what we're looking at here is two things happening to the variable and how do we get the variable by itself. Now, let me say this before we jump into our techniques. You may be able to look at this equation and tell me what number should go in place of n. We call that a guess and check method. However, what we're trying to do in this video is to build some skills so that if we get to more difficult problems, you'll still have the skills to be able to solve. So let's take a look at problem number 1. I like to think of there being an imaginary line at the equal sign, separating it into two sides of the problem. Now, we ask ourselves, what's happening to the variable? What's happening to the n here? Well, the n's being multiplied by 4 and being added by 9. Now, we're going to take care of the adding 9 part first. So we're going to do the opposite of adding 9. Now, the opposite of adding 9 is to subtract 9. I want you to see where I'm going to write subtract 9. I write it right underneath the plus 9, okay? I'm also going to subtract 9 on the other side of my imaginary line. You may think, well, why do you do that? Well, the reason we do that is because plus 9 minus 9, think of this as me giving you $9 and then taking them away, yields a net of 0. So we say that these two cancel each other out. And that leaves us with 4n on this side of the imaginary line. And over here, we can do -3 minus 9. That gives me -12. Now, if negatives give you a problem, you may want to use a calculator. I put a link in the description for the free Desmos graphing calculator. You can use that one. Did I mention it's free? All right, now look at your variable. What's happening to your variable now? It's being multiplied by 4. So we're going to do the opposite of multiplying by 4. The opposite of multiplying by 4 is to divide by 4. And again, we have to do it on both sides of that imaginary line. Why do we do that? Because multiplying by 4 and then dividing by 4 basically cancel each other out. And that leaves me with n equals -12 divided by 4, which gives me -3. And this is my solution here. Now remember, we called these two-step equations because there's two things happening to the variable. That means there's two things we have to undo to get the variable all by itself. Let's look at problem number 2 here. See that my variable is on the other side of the equation. That's okay. We're going to work the same way. Don't let that bother you. I look at my variable. I ask myself what's happening to it. It's being multiplied by -8. It's being subtracted by 11. So we're going to do the opposite of subtracting 11 first. You may be thinking, well, why didn't we do the divide by -8 first? We always take care of the add or subtract first when we're solving, okay? Think of it as going in the opposite direction of the order of operations. So the opposite of subtracting 11 is to add 11. Notice that I did it on both sides of that imaginary line. We know that taking 11 away, adding 11, those cancel each other out. On the left side of the imaginary line, we have 13 plus 11. We've got 24 there. Equals. And then I'm left with -8y. Now we ask ourselves what's happening to our variable. It's being multiplied by -8. So we're going to do the opposite, which is to divide by -8. We're doing that on both sides of the imaginary line. Multiplying by 8, multiplying by -8, dividing by -8, cancel each other out. That means I'm left with just a single y here. And then on the other side, I've got 24 divided by -8. That gives me -3. Interesting. We got -3 for both of them. That's purely a coincidence. I didn't design those problems to be that way. Oh, let's go on to, well, let me tell you this before we go on to number 3. I started out simple. I am gradually getting more difficult, okay? So if you're following along, you're taking great notes, Just know that's what I'm doing intentionally, is I'm gradually getting more difficult. So let's put our imaginary line here. Look at our variable, ask ourselves what's happening to it. It's being multiplied by negative 2.5, being subtracted by 3.2. So we're going to take care of this subtraction first. The opposite of subtracting 3.2 is to add 3.2. We do that because subtracting 3.2 and adding 3.2 cancel each other out. We're left with negative 2.5d equals, and then I've got 74.1 plus 3.2. That gives me 77.3. Now we ask ourselves what's happening to that variable. It's being multiplied by negative 2.5. And so we're going to do the opposite of that. And the opposite of multiplying by negative 2.5 is to divide by negative 2.5. Okay. Purpose of that was that multiplying by negative 2.5, dividing by negative 2.5 cancel each other out, giving me D equals, and this one I'm definitely going to my calculator. 77.3 divided by negative 2.5 is negative 30.92. And again, use that free online graphing calculator at Desmos. I've got it linked below for you. Okay. I hope you are starting to see the connections, the patterns. I like to do so many examples in my video that it becomes boring, almost to the point, because I want you to feel comfortable with our strategies, okay? I do the same thing every time when I solve these equations. Okay, let's look at this equation. You notice I put my imaginary line there. I ask myself what's happening to m, the variable. It's being divided by 3. It's being added by 11. So we're going to take care of the adding 11 part first by doing the opposite, which would be to subtract 11. Plus 11 and minus 11 cancel each other out, and that leaves me with m divided by 3 equals, and then on the other side of the imaginary line, 29 minus 11 gives me 18. Now we have to look at what's happening to our variable. It's being divided by 3, so we're going to do the opposite. The opposite of dividing by 3 is to multiply by 3. So I'm going to multiply by 3 over here, multiply by 3 over here. Multiplying by 3 and dividing by 3 cancel each other out so that we're left with an m equals, and then 18 times 3 would give me 54. Okay, friends, I hope you're starting to see this pattern, right? That we keep doing the same thing over and over again, asking ourselves what happens to the variable, taking care of the add subtract part first, then the multiply or divide. Now, as promised, I am getting a little bit more difficult each time, so let's take a look. All right, here on problem number 5 here, let me put my imaginary line. You'll notice that my variable is over here. And so I ask myself what's happening to it. It's being divided by negative 7. It's being added by negative 12. So we have to take care of the adding by negative 12 part first. We're going to do the opposite of adding negative 12. You may think that that means to subtract negative 12, and you're right. However, it's a little bit easier to add a positive 12 as the opposite. Okay, so again, I could subtract negative 12, but it's a little easier if I just add a positive 12 as the opposite. Okay, we did that because adding negative 12, adding positive 12 are opposites. They cancel each other out. So over here on the right side, I'm left with h divided by negative 7. And on the left side, I have 6 plus 12, which gives me 18. Now we ask ourselves what's happening to that variable. It's being multiplied by negative 7. So we're going to do the opposite. The opposite of divided by negative 7. The opposite is to multiply by negative 7. And we have to do that on both sides of that imaginary line. So Multiplying by -7, dividing by -7, cancel each other out to give me just an h. And then if I multiply -7 times 18, feel free to use your calculator there, I get -126. Okay. All right. My last two problems, you'll notice I've got fractions. I don't know why, but some people that bothers them. So I put two examples in here so that you'll feel more comfortable with having a fraction in your two-step equation. So let's take a look. Here at number 6, I ask myself what's happening to the variable. It's being multiplied by 2/3, being subtracted by 14. So of course, like our other problems, we're going to do the opposite of subtracting 14 first. So I'm going to add 14 to both sides. That leaves me with 2/3 a. Oops, should have mentioned subtracting 14, adding 14 cancel out, leaving me with 2/3 a equals. Now over here, 61 plus 14 gives me 75. All right. Now, I see that my variable is being multiplied by 2/3. So if I'm going to do the opposite, I could divide by 2/3. However, dividing by 2/3 is the same thing as multiplying by its reciprocal. So I'm going to multiply by the reciprocal, which is 3/2. So think of that word reciprocal as meaning to flip the fraction. Now, if I do it to one side of the equation, I've got to do it to the other side of the equation. Now, watch how this works. I see multiplying by 3, dividing by 3. Those cancel. Multiplying by 2, dividing by 2. Those cancel. And that's how I'm left with just a single a over here. Now, on the left side, I want you to think of this, on the right side, I want you to think of this 75 as 75 over 1. And now you can multiply across the top. 75 times 3 gives us 225. Feel free to use your calculator. And then on the bottom, 1 times 2 would give you 2. Now you can do division. So divide 225 divided by 2 gives you 112.5. And that's my answer here. All right, let's finish up with one more with a fraction. Now, before I start this problem, I want you to see that I have 6 minus 2/9 v, okay? And what I'm going to do is I'm going to change that minus to a plus, and I can do that as long as I change the sign of the very next number. So that means I'm going to rewrite my problem as -2/9 v plus 6 equals -14. You may say, well, why did you do that? I don't have to. But I've found that with students, it helps them if they can see the negative instead of a minus on that fraction. So what's happening to our variable v? It's being multiplied by -2/9. It's being added by 6. So we're going to do the opposite of adding 6, which is to subtract 6. You'll notice again, I'm doing it on both sides of that imaginary line. Now, adding 6 and subtracting 6 cancel out. It's the whole reason we did that. That leaves me with -2/9 v equals, and then over here on the right side, -14 minus 6 gives me -20. Now remember, we could do the opposite of multiplying by -2/9 by dividing by -2/9, but the same thing happens when we multiply by the reciprocal. So we're going to flip that and multiply. We're going to do it on both sides of the equation. Remember why we do that? Because multiplying by 9 and dividing by 9 cancel. Multiplying by -2, dividing by -2 cancel. And that gives me just a v. Now over here on the right side, we want to think of that -20 as -20 over 1. So that when we multiply negative 20 times 9, we get negative 180. And on the bottom, 2 times negative 1 gives me negative 2. And now we can do our division. Negative 180 divided by negative 2 gives me a positive 90. And this is my solution here. All right, friends. I definitely hope that all of the examples here have helped you with our strategy. Remember, we're trying to build techniques that work no matter how difficult or how easy the equation is. I appreciate you watching all the way to the end. Thanks, and I hope you have a great day.